Welcome back again. I hope you're doing well. In this session, we're going to take a look at the philosophy of science. So, as we start into this discussion, when we talk about science, ultimately science is a process of discovering how the natural world works. So, it is an active thing. So, when we're doing science, this is an active thing, something we're involved in. We also want to appreciate that science is a human endeavor. So it is subject to the various flaws that go along with humans. So, including biases, even though we try to remove those. So, keep those things in mind as we talk about science moving forward. Now, if we look at the early days of doing science, much of our earliest work in science was actually done by what we really better represent as natural philosophers. So if we look back to Socrates and Plato and the likes, they weren't truly doing science. What they were doing was natural philosophy, where they were thinking about the world and coming up with uh, explanations for the world. Now, this is different from science, where we are drawing evidence. What is that evidence? We're evidence based. This transition from natural philosophy to science, we can really, the first person we really attribute to doing true science using the scientific method is a gentleman by the name of Al Hassan ibn al Haytham in 965. You don't need to know him or the year. I just add that in here. And he actually was able to use the scientific method to refute the idea that objects emit light. So the idea back in the time before him was that if you saw something that was blue, it meant that that object was emitting blue light. And what we now know is that that object is actually reflecting blue light. So, and he was able to do this transition from natural philosophy to the science that we enjoy today is really, to a large extent, the implementation of the scientific method as a philosophy of how we do science. Now, when we think about science, one of the things that we want to embrace as we are approaching science is this idea of scientific skepticism. So, what this means is that we want to question ideas. And this is a great concept. So, if you think about skepticism, uh, as a teacher, do you think I want you to be skeptical? Do your other teachers want you to be skeptical about what they're teaching in their class, questioning those ideas? I mean, if you think about that, uh, what do you think? Well, actually, I do want you to do that. I want you to embrace that skepticism. So question those ideas. And so if you question ideas that we discuss in this course, then we can have a discussion about those and then further explore those questions that you have. So this is a cornerstone of science, is this idea of skepticism. So, is this okay? Is it okay? Not only is it okay to question other ideas, but is it okay to have your ideas questioned? Now, hopefully, we would want to embrace questioning of ideas. It's only through the questioning of ideas that we can further explore if these are valid. So, hopefully, we embrace these ideas of skepticism. Okay. Now, as we move on in exploring this idea of science, something we want to think about is how do we do science? And there are two main ways that we do science. The first way that we do science, and this is one of the things that people tend to miss, so I caution you, don't forget about this, and that is descriptive science. So in descriptive science, what we're doing is we're going out and describing the world around us. This is valid science. So within the last 2 years, we've had several species of plants and animals discovered. Here we've got a fish, a frog, a plant that have been discovered, which had previously not been described. And so by describing it, that is indeed valid science. That's helping us to better embrace or understand the entirety of the world. The other way that we do science is the way that you're probably more familiar with. I'm going to skip ahead here, and that is going to be the scientific method. So you've probably had to learn the scientific method before, and certainly I want you to be familiar with it. You may have learned various numbers of stages of the scientific method. These are the ones I would like you to be familiar with. The first stage of the science, before we move on, realize the scientific method is really the logical process of how science works. Be aware that when scientists are actually doing science, they don't record in their notebook each of these steps. This is really that logical progression of how we do science. So it will start off with some observation. We note some aspect of the natural world. In turn, this raises some question. This may raise multiple questions. In response to those questions, we will propose one or more hypotheses. So we'll get into that idea a little bit more. Hypothesis is really a potential explanation for an observation. We will then test those hypotheses, and that is indeed our experiment. And finally, we will draw our conclusions. Ultimately, our conclusions should be that they either support or reject the hypothesis. And keep in mind that our conclusions need to be restrained by the data. So we shouldn't go beyond what is suggested by our data. So these are the 5 steps that I'd like you to be familiar with. And one of the wonderful things about the scientific method is that this is fundamentally how we learn about the world around us. You've been using the scientific method since you were an infant, and you probably use this on a daily basis without formally thinking about it. So let me run through an example of a situation where you may apply the scientific method. So let's say we have an observation that your wake up alarm does not go off. Think about, usually I do a poll in class, and most people have experienced this. So ultimately, after your observation, at some point in time, that will raise a question. That question might be, why did my alarm not activate? So in response to that question, we will propose one or more hypotheses. Again, hypotheses are potential explanations for an observation. And so we might say, well, my alarm was set to PM instead of AM. Or maybe there was a power outage, or my phone battery ran out. Or perhaps I did not turn my alarm on. So we'll propose those hypotheses. In response to these hypotheses, we'll then test one or more of these. So perhaps I will, again, this is an experiment here. I will check to see if my alarm was set to PM instead of AM. Okay. So I can check that, and based off of that, I can draw my conclusions. Now, something to keep in mind. Let's say I test and I find that my alarm was indeed set to PM instead of AM. Now, does that explain, is that absolutely why my alarm did not go off? Well, it could be there are going to be other factors that could affect our results. Perhaps my phone battery died and it reset the alarm time. So the conclusion would be that, say, in this case, if my alarm was set to PM instead of AM, then that would support my hypothesis. Okay? But that would not necessarily mean that my hypothesis was 100% correct. Because again, it could have been that my phone died before the alarm went off and such. So we'll come back and talk about that a little bit. So this is just a simple example of how you might have applied the scientific method in your daily life. Now, we've used this term hypothesis and realized that you've probably been taught that a hypothesis is an educated guess. Well, I want you to kind of put that aside. We'll talk about why this is a bad explanation for a hypothesis in a minute here. What we want to think about is as a definition for a hypothesis, that a hypothesis is a proposed explanation for a specific observation. Okay? So a hypothesis tends to be very narrow in scope. It's dealing with that specific observation. Okay? It's not broad in nature. If we say, well, my alarm didn't go off because it was set to PM instead of AM, would that explain why all alarms fail to go off? No, that's not the case. So hypothesis is very specific to a specific instance. Okay. Another key characteristic of a valid hypothesis is that it has to be testable. Okay. If it's not testable, then it's not a valid hypothesis. Okay. Another key thing about a hypothesis is that it must be falsifiable. So not only must we be able to test it, but when we test it, let me take a step back. When we first propose a hypothesis, there has to be a way that when we test it, there's a chance that it could be shown to be incorrect. That's that idea of falsifiability, that it could be potentially rejected when we propose it. So if we think about this idea of an educated guess, say my neighbor Jimmy, his alarm didn't go off, and I'm asking him, well, what was up with your alarm? I didn't see you in class today. And he says, yeah, I'm thinking it's my house is haunted with the ghost, and the ghost, Albert, the ghost, turned my alarm clock off. And that's the hypothesis that I'm working on. Well, that's not going to be a valid hypothesis because one, is Albert the ghost testable? We can't test Albert the ghost. And could we falsify it? Could we show that Albert the ghost did not turn off his alarm? So we can't refute it. Therefore, that is not a valid hypothesis. Now, Albert the ghost in my neighbor Jimmy's situation, that may be an educated guess, but it's not a valid hypothesis. Okay? So something to keep in mind there. These characteristics of a valid hypothesis. Testable and falsifiable. Okay? Likewise, you may say, my neighbor might say, well, God turned off my alarm clock, just didn't want me to go into work today. Again, is God testable? Well, if we look at, history over time, and at least classical literature, generally testing of divine entities, not a good idea. And falsifiable. Could we reject the idea of a God? Well, we can't do that either. Keep in mind that science is strictly limited to the natural world, where a divine entity, by definition, is beyond the natural world. So, all right. Lastly, we want to keep in mind a hypothesis cannot be proven. Okay? So when we use the word proven, we mean that it is 100% certain. So when we test a hypothesis and our results are consistent with that hypothesis, we would say that hypothesis is supported. Okay? So again, proven means 100% certain. And if we think back to our characteristics of science, in science, our conclusions are tentative. That means our conclusions are subject to change. So we will, if there's a word that we don't want to use this semester, that's going to be proven. Okay. Again, because in science, our conclusions are indeed tentative, subject to change. Just as a little more interesting, I talk about this idea. Well, hey, I know what a hypothesis is, you might be thinking. In a survey that was done of Americans by Pew Research, what Americans know or don't know about science. This was back in 2019. A couple of the questions that were, two questions were about recognizing valid hypotheses. A little over 50% of Americans were able to recognize valid hypotheses. Okay, I want you to be within that percentage of Americans that can recognize a valid hypothesis. Okay. Now, let's play a little game here. Let's see how we're doing here. So, if we consider some statements here, are these correct or not? So, a valid hypothesis can be wrong. A valid hypothesis is not always testable. A valid hypothesis can prove a person's values. Valid hypothesis should be formed before making any observations. So pause the video, think about those. Now, as we look back at these, can a valid hypothesis be wrong? Absolutely. In lab, when we're testing a hypothesis, if your hypothesis is rejected, that's just fine. Okay. Should a valid hypothesis is not always testable. That is false, because we need to be able to test a hypothesis for it to be valid. Can a valid hypothesis prove a person's values? Well, one, science can't really deal with values. And beyond that, we're using the P word, proven. Okay, proven means 100% certainty. So that's going to be not a valid statement there. That's false. A valid hypothesis should be formed before making any observations. And that is false. If we think back to our scientific method, the first step is observation. Second step is questioning, coming up with a question. The third step is the hypothesis. So the hypothesis comes after making observations. We might take a look at another example of identifying hypotheses. If we look at these statements, which one of these is a scientific hypothesis? So pause the video, look at these here. All right, so realize the first statement, that's a value statement. Second statement, garden fairies make tomatoes grow better. Well, garden fairies would not be a testable idea. Hunting species to extinction is wrong. Okay, that's a value statement. Increasing the amount of protein in a cow's diet increases her milk yield. That is indeed something that would be testable. Okay. So, the last one, Bigfoot does not exist. And again, not testable. So not a valid hypothesis. So as we look back to our discussion here, think back to how we do science. So descriptive science, and think about the scientific method. Okay. We have descriptive science, and then hypothesis testing, that's the scientific method. So think about those steps of the scientific method. Be able to describe a hypothesis. in terms of things like falsifiability, testability, and so forth. And just something to think about as you're reflecting on this discussion. Think about an example where perhaps you used the scientific method in the last week and consider each of the steps of the process that you used. So, hope you enjoyed thinking about this. Again, if you have any questions, please ask, and I'll look forward to talking to you again next time.